Alright, so we're going to do adding radicals again, and we're going to do the next step here, okay? And the next step is, are these like terms, can you add these? And the answer right now is no. Square root of 18 and square root of 8 are not the same. But often we need to look at these terms singular, and we have to reduce them independently. So we look at just the first term, and when I see square root of 18, I see square root of 9 times square root of 2. And I'll put the plus sign. Well, we all know the square root of 9 is the whole number, 3. So the square root of 18 is equivalent to 3 square root of 2. And if I take my calculator and I check square root of 18 and 3 times the square root of 2, and I'll do it really super fast, I get that both of them are 4.242. So that's the same. Now I can do the same with square root of 8. Well, I see that as the square root of 4 times the square root of 2. And again, we're working from this property. You can do a product of radicals. The square root of mn is the square root of m times the square root of n. Well, if I do this, I get 2 square roots of 2. Now, if I re-look at this two-term expression, are they the same? And the answer is yeah. And I add them up, and I get 5 square roots of 2. So if I go to the top one and I type square root of 18 plus square root of 8 into my calculator, I get 7.071. If I do 5 times the square root of 2, I get the same thing. So I know I have the same value. And that is combining the things we've learned with equivalency and radicals. And really all this video here is practice of this concept. Seeing me do a few so you're going to be able to do a few in class. So if I set down my calculator, and we'll do the checks at the end, I have to make simplification. Now, again, I always look for perfect squares. 27 is equivalent to 9 times 3, so I would do square root of 9 times square root of 3. And the step I'm skipping is this right here. I'm skipping that step. I'm skipping right under one radical. I'm going immediately to 2. I'm thinking about what makes 27, and I'm going there. 18, again, we just did that on the front board. 9 and 2. And 45, I think, a 9 and 5. And I will write out the steps. You guys a lot of times try to skip this step. But I am just doing equivalency all the way across the board. You notice everything lines up. I know what 3 times 3 is. That is 9. And I know what 6 times 3 is, and I know that's 18. Now, are there any like terms? I've simplified to the lowest radical, and the answer is no. Square root of 3, square root of 2, square root of 5. Catfish dog. Cannot make a catfish dog. Alright, so we're done. Next one. 2 times the square root of 24 plus 4 square root of 48. Now, again, Mr. Anderson has lots of practice. I see this as 4 and 6. Now, 48, I see as 16 and 3 because I've practiced so much. You guys rarely see it there. You guys usually see it as square root of 8, square root of 6. So let's do it that way. So, alright? And I'll show you at the bottom how I do 48. Alright, 2 times 2, square root of 6, plus, I'm going to have to break square root of 8 down. 4 and 2, see how those line up underneath? I still have that square root of 6, keeping everything in order. 2 times 2 is 4, so I get this. Here I get, well, alright, square root of 4 is 2, square root of 2. Now, square root of 6, I know breaks into square root of 2, square root of 3. Square root of 2 times square root of 2 is 2. And I end up with 4 square roots of 6 plus 4 square roots of 3. 6 and 3, square root of 6, square root of 3 are not like terms. And again, we're done. And I can check the value. Now, if you do it the way I did, 48, and you think of it as 16 and 3, you're going to get to 4 square roots of 3 a whole lot faster than we just did. Up here, again, 18. And again, you're going to notice a lot of these repeat. And as we get good at these, some of these we'll just know. Alright, what's the square root of 2 times the square root of 2? Boom, 2. So I end up with 2 times 3 square root of 2, lining everything up value-wise, minus 3 square roots of 3, plus 2 times 2, I'm going to call 4. And again, any like terms? No like terms, okay? Again, we keep simplifying and checking. Last thing I want to do today is I want to look at some big radicals, all right? And I'll start at quadrant 1 and work my way around. Square root of 50,000. Now, the book teaches it any number of ways. I still like to think of it as, I think of 100 as the biggest radical I know, all right? 100 times 5 is 50,000. Square root of 100 times square root of 100 is 100 square roots of 5. Now, if you check the book, I believe the book is going to show it this way. It's going to say, you can do this way, and make it 10,000, which you know is 100 square roots of 5. I don't like counting zeros. I like using 100, because I know the square root of 100 is 10, so I'm going to do it my way. Alright, 2 zeros, 2 zeros. I need 1, 2, 3, 4, 5, so I need a 10. Alright, so I get 100, square root of 5, square root of 10. But you should realize that 10 can be broken down into 5 and 2. Square root of 5 times square root of 5 is 5. 5 times 100, 500 square roots of 2. And again, I'm going to leave it as 40. 100, 100, 100. Do I have the right number of zeros? 1, 2, 3, 4, 5, 6, 7. 1, 6, 7. Yep. 40 million. I see this as 8 square roots of 5. 10, 10, 10. Alright, I see this as square root of 4, square root of 2, square root of 5, times 1,000. Square root of 4 is the whole number 2, so I get 2,000 times the square root of 10. Alright, and again, any number of ways to do the last one. I see it as 70 and 100, so I get 10 times the square root of 70. Is 70 not going to break down? Some people say, hey, let's do a factor tree. Alright, I'll do a factor tree. And 7, 2, and 5 are primes. They don't match, so 70 is reduced. Again, like terms take work. It takes practice to see you simplify and you go. Again, keep practicing.